Ooh, that's a hard one. Okay, got minus 1/2 plus 1/3 minus. Oh wait, no, never mind. That's pretty easy, I think. Okay, so what I saw there was minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6 plus 1/7 dot dot dot. So here's my thoughts about solving this equation. So of course you can already tell, and here's what I'm going to do. First I'm going to add a 1 to this side, and let's say this is x. We're going to add a 1 to this side. And so 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6. So this is a little bit hard to think about, but what I'm going to do is going to put 1/2 plus 1/12. Wait, no. Okay, so this is 2 over 2 minus 1 over 2. Wait, let's see. Okay, this is actually kind of difficult. Let me rethink this. All right, so what I'm going to say is minus 2, minus 4, minus 6, minus 8, etc. is just going to be it's just going to be half of the harmonic series, which itself diverges. And 1 plus 1/3 plus 1/5 plus 1/7 also probably diverges. So, okay, let's see. What can I do to solve the alternating harmonic series? Well, let's see. This is a very tricky question, actually. So I think we can solve it using telescoping, though. So we have 1 minus 1/2 is equal to 2 minus 1 over 2. We have 1 times 2. We have 1/3 minus 1/4 is equal to 4 minus 3 over 3 times 4, and so on and so forth. So what's actually going to happen is this is going to be 1 over 1 times 2 plus 1 over 3 times 4 plus 1 over 5 times 6 plus 1 over 7 times 8, and so on and so forth. And hopefully I can figure out how that telescopes pretty quickly. So I'm pretty sure this converges. Just to be sure, I'm going to write it down. So AN is just going to be equal to, well, this is A1, this is A2. So this is just going to be equal to 1 divided by 2n times 2n minus 1. So that means AN plus 1 divided by AN is equal to 2n times 2n plus 1 divided by 2n times 2n minus 1. This is going to be 2n plus 1 over 2n. No way this diverges. Oh, I think I did this the wrong way. Wait. If an plus 1 divided by an is greater than 1, that implies that an plus 1 is greater than, no, that's wrong. That's definitely wrong. So let's see. We have 1 over 2 plus 1 over 12 plus 1 over 30, so on and so forth. And so, oh crap, I'm dumb. Very clearly. Okay, so this is going to be 2n times 2n minus 1 times 2n plus 2, 2n plus 1. Wait, that makes it even greater. Okay, let's see. So, does this diverge? No, it can't be. But, oh wait, no, I had the whole thing reversed. So this next one is 12/30 of the original. Oh yeah, this would be inversed. Okay, so this doesn't diverge. So we have 1, okay, plus 1 over 56 plus 1 over, okay, this is definitely a tricky question. So I'm gonna say this definitely converges, but I have no idea to what it converges to. So let's see. If I can figure it out within this time span, it would be great. But my guess is that I probably can't. So I'm going to make one last desperate attempt. This is just a half of 1 plus 1/6 plus 1/15 plus 1/28. Okay. Does anybody have any ideas of how to solve this converging series?
not actually solving this. I am getting two answer from this by solving this one.
Let
Two
me see
answers.
that. Two answers.
Two
Okay.
answer by solving this.
Okay, what did you get?
That if I use this method, then I am getting as this
Let
this
me
series
see. Okay.
minus one.
2s1 is equal to, oh, sorry. 2s1 is equal to this. 2s1 is equal to 1 plus s1 plus s2. Okay. S1 minus S2 is 1, S2 minus S1. Okay, so here's what I think the problem is with this approach. Because I'm pretty sure you can't just add them like that because S1 and S2 are both series that diverge. It is only when they're subtracted do they converge. So you can't really do proper arithmetic in this way. And of course, if you do, you get this paradox that leads you to two different answers. So don't try to add or subtract diverging series. Instead, that approach might be helpful for what I'm facing right over here because, of course, I'm still stagnant on. I could be using every even term or every odd term. So my advice is just don't sum or subtract diverging series. That leads you to paradoxes like those. Thank you. Just don't add or subtract diverging series. Both of these diverge. So adding and subtracting them leads to some very bad arithmetic. It's the same way that the sum of the natural numbers is minus 1/12. So uh, just don't add or subtract diverging series because it leads to not good results, like a paradox. None of your algebra is wrong here. It's just that you can't sum two diverging series.
Is there any reason behind this?
It's just that algebra messes up when you consider these. So essentially, what we're trying to do is find the limit of these two. S1 is a limit of this sequence, and S2 is a limit of this sequence. But the problem with S1 is that it approaches infinity. The problem with S2 is that it also approaches infinity. So by multiplying it by 2, you're multiplying 2 by an indeterminate number. So essentially, you're doing algebra with numbers that don't actually exist, which leads to paradoxes like these. It's like trying to divide by 0.
We solve this kind of uh, this this type of problems by this
Yes, that's a limit.
but this one we are
But the thing is,
doing
this series.
another.
Oh, did I turn it off? This series. Oh my gosh. This mic. Oh, this series converges. Of course, this series actually converges to a number. So we're not doing arithmetic with dead numbers. But here we are doing arithmetic with numbers that don't actually exist. As you know, the harmonic series diverges. So of course, half of it diverges too. So doing arithmetic with numbers that don't exist doesn't really work in comparison to doing algebra with numbers that do exist, like root 2, root 2, root 2, etc. So essentially, just don't do math with sums that diverge. Does that answer the question, or do you have any doubts?
Not actually satisfied. I have to
Hmm.
think.
Okay, so just I guess one thing to say is this approach is infinity, and I don't know what this approach is, but it's probably also infinity. So you can't really do math with an indeterminate
This
number.
this is not approaching to infinity because this is getting smaller and smaller. So
Oh, yes, but that's the
so
same thinking behind the harmonic series, not approaching infinity. The truth is, the
it is
harm.
like we like the GP we
Oh,
use.
okay. So let me just introduce you to the convergence test real quick. So if an plus 1 over an, the limit as n approaches infinity, is greater than 1, then this can't hold. So of course, S1 is 1 over 2n, right? Right? So that means that 1 over 2n plus 2 divided by 1 over 2n has to be less than 1 for this to converge. But of course, you get 1 over 1. We get 2n divided by, oh wait, 1 second. Yeah, so you get 2n plus 2 divided by 2n here. And when you divide this by this, you get n plus 1 over n. and n plus 1 over n approaches 1 as, okay, you know what? It's getting a little too complicated. All I'll say is 1/2 plus 1/4 plus 1/6.
You have another
This
question.
approaches ln of
Download
x,
session
which is a function that diverges.
Yeah.
So you can
So,
prove this, but
shall I
I'm not
continue
going to
with
do
that?
so right now. But all I'll say is that this does diverge, although at a very slow rate. The harmonic series is actually very paradoxical for this reason in calculus courses. Many people often get confused on this. So it's a good question, but essentially this is indeterminate, so you can't use it for math.
You are saying this is matlab, getting not getting closer to zero, but getting bigger.
Yeah, even though it's getting closer to zero, it's not getting closer to zero fast enough. Eventually, all the terms will be approximately the same value. And when you add them up, then you get something that diverges. So just use this convergence test. The limit is an plus 1 divided by an has to be less than 1. Otherwise, it doesn't converge. Does this? No, it doesn't work. Okay, if
Next question.
uh, I have to find some better way to explain it. Okay, so essentially, mm, what I'm going to do is we know that if an plus 1 over an is is less than 1, what does that mean? Well, that means an plus 1 is less than an as n approaches infinity. So a good example of this would be like 1 over 2 to the n. You got 1 over 2 plus 1 over 4 plus 1 over 8, etc. But this doesn't work for 1 over 2 times n, which is the series that we just had. 1 over 2 plus 1 over 4 plus 1 over 6, and it keeps going. Why? Well, we just look at this. 1 over 2n plus 2 divided by 1 over 2n is equal to the same thing as 2n plus 2 divided by 2n. And this is equal to n plus 1 over n. And no matter if you take the, oh wait, no, sorry. This is equal to 2n over 2n plus 2, which is equal to n over n plus 1. And here's the issue with that. The limit as n over n plus 1 approaches 0 is 1, right? Because you get 3 over 4, 4 over 5, 5 over 6. Eventually, n over n plus 1 approaches 1, right? Which means that at some point, the difference in all the terms is minuscule, which means adding them up will make it diverge. So that's unfortunately the best explanation I can give, but I hope you understand. Okay, you can take your time. Thank you.